Welcome back to our Scala class here at ProseMind, and let's talk about our final group assignment, where one of the choices is to make a game, in fact, or also you can make some application, which really there's not much difference between a game and an application, really. So we'll be using a simple game called NIM today as an example. How do you make a game, right? What are the requirements? What are the parts? What are the moving parts that consist what the game consists of? So let's get started, and let's move again let's see first what kind of game it is going to be. So if you have never heard of NIM, it is actually one of probably the oldest games in the world, right? It's been played again pretty much everywhere around the world. Well, in these days you can use matches like this, right? But where you take the object of the game is either to be the last one to take the last match or to force the other player to take the last match. There are two versions of this game, right? But we will be using at the beginning, right? The game rules are not that crucial, right? Well, they're crucial, of course, for the game, but we're not going to use the complex version first. We'll just use a simple version where you have the rows don't matter. You just have a whole bunch of matches, and you want to basically force the other player to take the last match. So that's a game we are going to be implementing, right? It's a game where the last player to take the match loses. Okay, so that's a game. Okay, I'll copy this and let's get started with our Scala playground, right? So it will be day 26, right? On new game, Scala class, day 26, NIM, right? On add, extends app, of course, right? And we'll do so game to do implement a basic version of NIM, right? So that's to do again. So in developing your app or your pretty much anything, whether it's a game, whether it's a data processing application, right, you need to have, well, some approach. There's two basic big ways of writing, just like writing in literature. Whether you start with this big idea and you develop a plan, or you sort of wing it. You go from the bottom up. You start writing something, and well, maybe good things happen, right? In literature, of course, I think it's more common to do the creative part where you start from the bottom up. Of course, some writers really plan everything out, right? But again, even in software, not everything you plan out will come out exactly the way you want, right? So yes, but still some planning is essential, right? So let's write some to-dos. I'm a big fan of this to-do based development, because remember, again, you have these to-dos available. You have 109 to-dos here, right? So we have a lot of to-dos in our project, right? They are widely supported by different productivity applications, not only IntelliJ, right? To-do is everywhere, right? It's the easiest way to organize your code of things to do, basically. Well, that's what you use to-dos for. So, but let's use that to plan out our application. So we want to have, well, so what's general, pretty much any application will have three big steps, right? You'll have we'll have to do setup config, right? To do main loop, main application loop, game loop, right? On again, it could be single. Sometimes it could be a single loopless, right? It could be loopless, right? For example, if you're processing something, if you do something only once, if you process data only once, right? On cleanup, you know, close database connections, close database connections, files, etc., right? And so on, you know. But again, sometimes, you know, sometimes no cleanup is needed, right? So setup, you know, you set a game, set what's data state, what is needed for the application. Of course, this is extremely simplistic, but because main is where the meat, so to say, resides, on where you can have maybe more data coming in, of course, obviously. But in general terms, right, this is your, well, basic your skeleton or your framework, right? Really basic framework. So how does it apply to NIM, right? So we'll need some state. So we'll need to see setup to do for NIM. We'll do, as far as NIM will go, NIM specific, right? We need to do's, right? Yeah, we can do like that. I guess I can't put s here. It doesn't apply, so we need to do it like this, right? Okay, so we need some constants. Start with 21 matches, right? We will start with 21, matches tokens, right? We initially implement PvP. It's easier, player versus player. Computer only checks the rules, right? That's easier. PvC, player versus computer. You will need to add some logic to the computer, right? Here's to do that, right? I'll do all these to do's, and then this is the setup, right? And so we'll of course get what do you need for setup. So let's do the setup stage, right? So setup on get player names, right? To do, of course, I could be writing all of this, right? So that's it for setup, right? And here main loop, right? And there's no cleanup, and here's no cleanup, no cleanup at the moment, right? So that's our structure, right? Very simple, right? So we start with 21 matches, right? And we'll have a main loop while there are some matches, play on, right? Again, some idea. Of course, you don't have to write all this down again, but some way of planning is needed, right? Maybe on a paper, maybe, well, you could do it in a spreadsheet, you could do it on a document, right? Or a text file. I usually prefer using just the code itself, right? And you can commit it, and then of course you have the initial plan, right? It's text-based, right? Easy to follow, right? And again, there are various tools which actually extract these to-dos. But okay, so let's start. So what do we need? So we'll start with the initial state. Right, we need initial state. So we'll do something called, let's say, starting count will be 21, right? That's easy, right? So val, because it's not going to change for the moment, right? On game end condition will be 0, right? Okay. And let's see the rules. Well, here in this version where you have multiple rows, right, you can take any number, but we'll do something simpler. We'll use the one with the 21 game. We'll use this one. So this is actually the 21 game, right? So it's a misère game, meaning the last player loses, right? So, right, and this is a very simple one, right? So, so this is there's the samples, there's strategy, also very simple strategy again. So we'll be concentrating more on the program structure than on the actual big, some sort of very intense strategy. So subtraction game, so we'll be using this variation, right? So this is what we actually, for now, so this is the variation, right? Okay, so and how many are allowed? 1 to 3, right? 1, 2, 3. Right, so let's do that. So min move, right? One again, no plan, of course, no plan. I think it was Clausewitz. No plan survives first contact with the enemy, right? Of course, this was, who said that? I think it's Clausewitz, right? Yes. Again, German field, but I think it's even older, right? It's really older, right? Maybe I think it's from like, I think really, this is Prussian, like from 19th century, right? But this is really a question who was original, probably not an original idea, right? So who said it first? But the way but it's normal. It is normal, especially in agile. You probably had the agile meetings, idea of agile development, right? Especially in agile, right? Agile development, yeah. To adjust, right? As you develop, right? I mean, this is completely normal, right? So maybe you have a client comes up with new requirements, right? Your manager, or or even yourself, right? You'll come up with some new ideas. Like again, as you start developing, you might have a one idea. Again, analogy with writing a book, right? You have one idea for a book, and then as you write, well, you come up with completely different story, right? So again, some requirements might change, right? And actually, some program, well, some specifics might change. So things do change. So we want to be open to this change. Okay, so yeah, right. So what else? Let's implement these rules. So what else we have? Max move, right? You'll have 3. So far so good. These are all settings. For now, let's do that. And well, let's do for now. We'll do players 1. Player A will be read line. Of course, you know that how to do this, right? This is setup, right? Read line. Player A, what is your name? Right? We know how to do this, right? And well, player B. It's always nice to be some little personalization, right? Player B, what is your name, right? For now, this is player. This is two-player version to do, right? So we can safely, right? Well, actually, let me commit this, right? Since we already almost so far. Let's get something on the screen. Import readline, of course. We know how to do that. There we go, readline. And let's print a greeting. Let's print a greeting, print line, S player A, and player B. Alright, something like this. Right. Let us play NIM. Okay, so let's start with that. Let's check, right? Let's run this. Let's first iteration of our program. Really simple, but at least we'll get the first early win. It's nice to have this early win. Again, that's why even a simple print line. Again, one of the oldest tricks, right, is to actually have something working. It's like going to a gym, right? You go gym for 5 minutes, right, and then you might stay there for an hour, right? It's another trick, right? So again, you can get something easily done, and then you can proceed. So let's do Valdis, right, on Liga, right, on, yes. All right, so it works, right? Everything works. All right, so let's commit this source, right? NIM stub, right? Getting player names, right? Stub is meaning like a sort of empty frame basically for your application, right? We have a little stub, right? I should have probably done this commit a little bit earlier, before when I had my to-dos, but again, this is good enough already, right? And of course, there's lots of to-dos, right? It's warning you have not finished doing everything, right? Which is of course true, right? Okay, so I can safely release this, get rid of this to-do, right? Okay, and right, so do we need anything else? We have, right, so starting count, but we will need, so far we have had only values fixed, but any application, of course games included, will have some inevitably in most applications, especially games, right, we will have some state, you know, that we want to keep track of, right? Here it is simple, here it is simple enough state that we can use a single integer? Well, you can use a few variables for more difficult, for more at some point we will want to structure this game application app state into a class, you know, into an separate, maybe into an object, based on some class, you know, class, right? That might be a better way of structuring. For now, we are putting it inside or this object, but I maybe want to separate into a separate object with some class. Okay, so for now this will be game state. I'll call it, right. It will be, I think, in the initial state will be starting count, of course, right. This is going to be a variable, right. Of course, integer, right. And what else do we need to count? So what else do we need to keep track of? We know how many matches we have, but what else is needed? Let's think about it for a moment. Well, what's important if you have a two-player game, right? You need something whose turn it is anyways, right? Who has to play, right? Whose turn it is. So let's make a simple Boolean variable whose turn it is. But then, of course, how would we, for two players, we can use a Boolean, say, is player, well, A or B, but let's do A, right? A turn, is A player's turn, and we'll say it is true, right? That's initial state, right? We start, of course, right? So A goes first, so A goes first, right? Okay, right, of course we could adjust this, right? So that's our starting setup, really, right? We could put this all in a single separate setup function. We'll do that later, right? And we are ready to play, right? We are ready to play. And now we come up to the main loop, right? Getting players' names. Let's do the main loop. And what's our game name loop, right? So this is where we're gonna do this PvP, right? So what's our condition? So in a main loop, we'll have some sort of condition which says, okay, you have to keep playing, right? You have to keep working. Maybe you have to keep getting data, right? There's maybe a quit exit condition. So what's our exit condition? Well, here we'll do a simple. For now, they'll have to play through immediately forever, right? So, well, we'll keep decreasing the count, right? And we'll make players play till the end. We can add early exit later for now, right? So let's do this loop. So while, like something, right? So while true, for now I'll leave it true. While true, right? For now, right? And we'll figure this out, right? So, well, true, right? Play the game, right? Play the game. Play the game, right? Play the game, right? Okay, so we need to change this to something. So we have game state, right? Starting count, right? Or maybe I'll change this again. It is a game state, right? So current state, right? Current state, current match state, right? Current state. I'll call it current state, right? Current state, right? Right. Right. So while current state is, well, what's our game condition? Game end condition is 0. Okay, that's easy. Game's end condition, right? So while current state is more than game end condition, right? We keep playing, right? So let's see. So right. It's if we'll get the date, right? So let's get the actual condition, right? So from using this player turn, right, we'll get the actually whose turn is it, right? So current player will do this. Excuse me about that. So while current player will be who? Well, if this is true, this is going to be player A, right? If else, otherwise, it will be player B, right? Okay, so this is sort of, we get the information about whose turn is it anyways, right? So if is player turn, right, then it will be player A, right? Else player B, right? So simple, right? We use ifs from a Scala, makes it easy, right? So we assign, right, inside our game loop, right, this local value, right, just for that particular turn, just for the current turn, right, we get the value, right? Again, simple, again, naming is important, right? So if it's player say turn, right, it's player A, otherwise it's player B. Of course, we could we can already start thinking for if you had multiplayer game, right, you have to have something more, some function which assigns this whose turn is it, right? But the same principle, right? Here it's the simplest one with possible, but you can expand it, of course, right? So now we print the game state, show the game state will be print line. There are currently there are what's our current state? Matches on the table, right? And now let's do the move. So do we have val move, right? Or the right? So how many read line? How many matches do you want to take? And we'll have current player, right? Current player. There we go. Current player. Right. Take, and I'll do. We can of course adjust here. 1, 3. Right. Right. And now of course we close it, right? Like this. Right. Okay. And we'll again for now we're not adding any error, no error catch, no error checking. Checking here to do error checking, right? Error checking maybe at some again for later, right? Because we're letting players to enter any numbers, right? We'll do some error checking, but for now we're doing to integer. So this is going to be integer. It's going to be integer. Okay, so let's continue our Scala class and let's recap so far. We have our setup. We went through, we set up the initial game conditions. We get some information from players. Again, it's part of setup, right? And then we have main loop. And again, so we have the current game state, and it has to be larger, again, than the game end condition. And we get the current player, right? It's part of this game state, these two variables, right? And then we show how many matches are there on the table, and then we are gonna get the move, right? And we are gonna want to limit the number of matches according to the rules, right? We'll want to do that, of course, right? For now, right, we will do this. So game current state, right, is equal what? Move, right? Very easy. So this is a really easy part, right? So, right, so we'll need to limit this somehow, right? And then, right, and then I'll show you a little trick. I don't know if I showed you before, but the current is a player turn is equal to not is player turn, right? So it's a toggle trick to change a boolean to reverse version of current, right, of present, right? So I'm saying the is player turn is whatever. If this is false, this is true. If this is true, this is false, right? And we keep going, right? So we play the game, right? And we keep going, right? So let's see. Yeah, we keep going, and then we check, right? And let's check the winner, right? So let's do winner, right? We already have a simple version of the game working. So let's see. Val winner if is winner, so is player a turn, right? Will be player if it is. So what happens this? So let's think this through. Who is gonna be the winner, right? if it is, if you took the last match, right? This means during this, so you took the last match, right, or last few matches, right? Meaning you lost, right? So the winner will be whose turn it is actually, right? The winner will be player A if it's a player's turn, because he has nothing to take. So he says, okay, I win. There's no matches, right? So else player B, right? So otherwise, of course, going to be player B. And also loser will be, of course, if it's not equal, right? If it's not a player turn, it's player A, right? Right? Else player B, right? It's vice versa, right? Player B, right? Something like this. So again, if it is player say turn, right here, he has to keep playing, but the game has ended already. He has no matches to take, so he has won, right? This is loser is the one who has to take the last match. So again, if it's the loser, same by reverse logic, right? If it's not player's turn, right, he lost, right? Because obviously it's player B turn, so loser is A, right? So okay, so that's so we have the game state. Let's print the congratulations, right? So I will do that PVC late some other time, right? No cleanup, right? But we just to do, game state and cleanup here. We just print some stats later on to add saving to the database, right? Maybe some stats, right? Some basic stats, some game state on congratulations, right? Stats, etc. Right? So okay, so winner on, we can just do print line, right? S game ended. On congratulations, winner. Better luck next time, a loser, right? Okay. All right. And now, of course, to do would be keep implement multiple games, right? Right. So we have a single game loop. Maybe we want to implement multiple games, right? Well, that will be again come later. So let's do this. Let's check if this works, and we can commit our first version, which actually is a full game, right? A really simple game, but it is actually a full PvP game, player versus player, right? And because it's really easy to play, right? Okay, but let's play. So let's run it. So I'll do val on Bob, right? Right. So I'll take 3, right? And Bob will take 2, right? And again, I'm playing politely, right? So, but since we have not implemented this, so to say, cheat protection, I'll do 15, right? So I'll be evil. Well, I'll take 15, and poor Bob can take only 1 match. Well, thing is, Bob is smart, right? I'll show you another trick, right? He'll take -10, right? On there's 11 matches. Oh my, right? So you can see the game works, but of course we need to implement some safety checks, right? So people don't break the rules, right? So, but let's again. I'll do 8 on, and now I'll let Bob take 3 and lose. I want to win today, right? So yes, I won, and Bob will win next time probably again. So. We have a nice working game, but we have, of course, plenty of work to do. Okay, so let's commit. Let's commit to our game. All right, so working game, working first version, right, of the game. So again, you want to commit, of course, things which do work, right? Check if it's actually, working, right? At least even if there's plenty of work to do, there's always work to do, right? And there's nothing is ever finished. But we only have something, a first prototype, minimal viable prototype, right? MVP, right? There's a term, right? We have something like that. But let's implement. So we have some time. Let's implement some logic for saving this move, right? So how do we do this? my recommendation is to move this into a separate function. Let's come up with a clamp function, right? So we would like to, I don't think Scala has one, but we can build it. We could even do this in a, you have a utility for clamp, right? So what's the idea of clamp, right? So we'll do a logic, right? So we'll create our fun. So def clamp move, right? Or clamp move or clamp, right? So clamp move, right? So we have move, which will be an integer, and we'll have a minimum will be also an integer, and it will be, well, what's the minimum? Well, minimum will be probably, we can do from min move, right? Right? Can we do this? Yeah, we can do that. Yes, and max will be integer max move, right? We don't have to do anything, right? And well, and then, well, for now that's enough, right? So that's enough for now. We want to return int, right? Int, right? And so how would we implement this? Right, this, right? And for now I'll return, 100, right? To do fix me, right? Fix me, right? Okay. So again, it's probably better. Again, I put something, some false data, but of course, even better be to just not compile, because if you leave it not compile, if I remove this, right, you have to do this, right? You have to fix, otherwise the program will not work. That might be even better way of doing it, right? So if move is over max, right? What do? We are going to return the max, right? Yeah, okay. And else if move less than min, what do we return? We return min, right? And otherwise we return, else we return move, right? So this is, right? Again, you could do a larger equal, also lesser equal. Here it would be still works same way, right? So let's think about this a little bit. So if it's a move is over max, you return the max, right? Otherwise you return the min. Okay, now another question is now, well, I sort of put the default values here, but probably better actually take them off, because we want to move them here, right? In the min state, right? Min max. Probably put them in, maybe not default, right? Because that might be hidden somewhere. I mean, within the simple game, yes, but in a general, if you want to make this general function, probably don't want to have these as defaults, right? So we'll move these off for now, right? And we'll have the here, right? So we are going to limit this, right? So how would we do this, right? So we are going to clamp. We could do a limited move, right? We could do the safe move. I could do maybe a safe move. Let's do that. Let's do a val safe move, right? Or clamp move, right? Will be, so clamps move. We'll have move, right? Then min move, max move, and that's it, right? So safe move, right? And we have to do this safe move, right? Safe move, right? So again, of course, you could have saved, these are temporary game variables, right? We could have, of course, skipped this part, right? Of course, we could have immediately this, right? But again, I mean, this way is, I think, more for educational purposes. I'm keeping it in multiple variables, right? You could just do a single variable as well, right? Skip the save move, put the clamp here, right? Okay, so clamp move, min move, max move. Okay, let's hope we put it correctly. Min max. And here, of course, inside the logic is a little bit different, but outside, yeah, min max. Okay, so min move, max move. Again, you have to, of course, check this. Yeah, min max. Yeah, looks okay, right? So now, right, do we want to put some, we'll do a verbose logic, right? So maybe we'll put some logic afterwards. So let's see. Let's run this game now. So we'll do Alice and Bob, of course. Bob, right, on, right. Alice will take 50. Ah, okay, it's already working. Bob will take minus 23 on 17. Only one match. Okay, looks like it's working, right? So I'll do 3, Dog will take 3, 0. No, you have to take 1. You can't do 0. Okay, right? So it looks like it works. Okay, so who's gonna win? There are 3 matches. So how many matches should Alice take? Well, if you want to win, well, you can't. You don't want to take 3, right? Because then, well, then you lose, right? You took the last match, so you want to take 2, right? There's 1 match on the table, and poor Bob, well, he has to take 1, right? Or anything, but he'll take 1, right? Question is 3, right? Doesn't matter if he takes 3, it'll be go over the the current state will be less than the game end condition. So well, again, he'll take 2, doesn't matter, right? He loses, right? So game end, congratulations Alice, better luck next time Bob. Okay, so the clamp moves. We can add a little extra thing. Maybe we add some message here, right? So let's do a message, right? I'll do something like this: verbose equals probably true by default, right? So this would be a verbose boolean, right? Yeah. Okay, and we'll add a little message, right? If verbose, we'll do a print line, right? We'll do print line, move something like this. Move was too much, is too much, was too much. You will have to settle for max, right? On here again for minimum, do if verbose, right? Print line. See how easy it is to adjust, how your program starts growing with all the extra logic, your extra features. You can come up with a million little features you might want to add. So here again, of course, if you're doing it for yourself, right? Even then you need some self-control, right? You need to focus on the crucial parts, right? You will have to, it's too little, you'll have to live with, you'll have to settle for min, right? Okay, so now, so this is, true by default, it's gonna be verbose, right? Maybe you want to turn it off, right? But for now we are going to, right? So this is like having it true here, right? So let's run it, right? So we add some logic, right? Again, so notice again, in this little function, as those who, just a reminder that we are returning integer, this is a return. We have 3 returns basically, right? Because this is the last code of this. Remember, in our Scala programs, the last entry is return, right? So these are returns, right? So return, right? Return, and of course return. Since this is last, since this is the last line of the function, right? Right, because this if, right, there's nothing here. If I put something here, right, you know, maybe something, right, this will break, right? String, right? So whatever is last, so you can have multiple returns in a Scala program, right? Even without saying, because you, of course, if, right, you have 3 branches, right? This branch, or this branch, right? So everything's good here, right? So let's run it now. So we'll have a little extra logic, extra debug messages maybe, right? So again, so Alice and Bob again, so I'll do, no, okay, excellent, we have a message already, right? And we'll do minus something, and again, too little, right? So now we can do, okay, hopefully the players now realize it's useless to resist, so they play the game the way you should play, right? So 2, and again, you can always see the logic, right? You can always start thinking about the logic for the players. If you want to do PVC, which we'll do probably later on in the next segment, but so the logic, of course, is reminder. So if you have to do a reminder, there'll be, for smart computer or smart player, you want to have some sort of modules, right? If you do divide by 3, so you have 8 matches, you probably, let's see, do you want to take 3? You want, so if you have 4, you want to take 3, right? If you have 3, so 2 or 1. So you don't want to be left with, let's see, well, we'll figure this out, right? So 2, right? So 2, let's see, Bob can take 2 2, right? And then Alice is basically lost, right? Yes. So yeah, 4. So 4 is the winning condition, right? I mean, 4 is a losing condition, right? 4 just like 1. 4 and 1 and 7. So those are the losing conditions. No, 1, 4. Yes, 1, 4 exactly. No. Let's see if it's 4 matches. Yes, 4. I think 8 then. Right, 8. Yeah, 8 is losing as well. Right. So yeah. So you always want to add up to. So if it's 4, Alice. So yes. So if it's 4, Alice can win. 4 is a winning condition, right? So because Alice can take 3, and then Bob is, well, out of luck. SOL, right? Bob is going to lose. Okay, so Bob loses. He can try whatever he wants. He can take minus something, but that's no good, no use, right? And Alice won. All right, great. So we have some safety. We have nice little function already for clamping. Limiting the moves, right? Some safety checks, right? And let's save this, right? Let's save this, right? And NIM with safety with move clamping, and let's do that. Okay, I think that will be already a good start. Let's think about a little bit what else would you want to do, right? We could move this again. We could move these variables into a single case class, right? Because we have current state and this player turn. We only have 2 data points really for now, but we'll want to probably also do more. Maybe we want some more data later on. What else? So lots of things to do. We could save whenever game ends. Save. We could add an early exit. So let's do something simple. Maybe, well, or maybe we'll leave that for exercise for you, right? How to add an early exit, right? We could do that, right? So we did the limit, so we can safely exit this one to do less, right? That's good. We have safe move, right? And maybe we also do the error checking here, right? Maybe do some error checking here. That would be a good idea as well. Maybe, right? Before we do to integer, right? Input, right? We could do input, right? And then only then would we actually do the move to integer, right? We could do that, right? That might be something we want to do. What else? So PVC, maybe we could add a simple computer player, right? That's another thing to do, right? And what else? Right, so plenty of things to do, but we learn again. So what did we learn in this exercise? You need to set up, of course, how to set up some initial conditions, right? How to set up the main loop, right, of your, well, again, for your application, of your game, whatever you have, and well, then you have some saving, you know, again, cleanup, basically, you know, where you exit the application. All right, and let's in the next video we'll look at some exercise, possible exercise for this application.